All right, so welcome to the experimental March edition of the Go user group. We are being hosted by Blacklane, and also our talk for the day is by Blacklane. And quick thank you for Aerospike for donating this or allowing me to use this Zoom Pro account, which accommodates all of us and will not kick us out within 1 hour. Also allows all the cool sharing and setting manipulations. It's a real-time NoSQL data solution, great for high scale, fast time, and great performance. And I will be handing over the mic now to the Blacklane team. I guess, Tom, will you be introducing the company?
Yeah, I will. So, I've got to press OK. Howdy, Tom Bradford. I'm the Director of Engineering here at Blacklane. And just a brief background of the company. We're about 8 years old at this point. We initially started in order to serve limousine service to the Berlin-Brandenburg airport that was about to be opened. We had to pivot, obviously, but things are going well. And right about a year ago, we started to explore the world of Go as far as our service landscape was concerned. Today, we have a couple of our engineers here to talk about Go as it relates to implementing serverless architecture. And that will be their presentation. Oh yeah, and let me remind you, we're going to do a raffle. And the way that this is going to work is that you're going to click a link that's going to be in the chat. Anderson has just posted it. And at the end of all of this, we're going to randomly choose somebody to win an €80 Blacklane voucher to do it with as you please. You could even sell it if you want to. So just stick around for the end of it. And in the meantime, click on that link in order to enter the raffle. Okay, without further ado, I'm just going to hand it over to Jose and Giuliano.
Hello. So I'm Giuliano. Today we're going to talk about our composable and scalable serverless architecture that we created in Go here at Blacklane. Okay. So I'm engineer. I'm senior engineer from the engineering department here. So my main responsibility includes the booking funnel where people can book our services and every connected experience that our customers have. And why I'm working for Blacklane, I really like the set of values that the company have internally. It has a really work-life balance, and because it's really fun to work here since we have a lot of liberty. Right?
Hi. So Jose, I do premium customer integrations. And I work at Blacklane mainly because I like the autonomy that teams have. Teams have a really good set of ability to make decisions over the architecture that they work on, the way that they work on, and the different tools that they use to work. And it's one of the things that I really like.
Okay, so this talk is based on a project that we had internally, which was called Tahiti. And the main idea was to prototype and experiment with new technology to creating something better, to create something better in terms of architecture, right? So we are going to basically talk about what were the motivations and different aspects of this project, and then we are going to dive deep with Jose into the code, just a part of the code. So the idea was to actually create a different mindset where people will probably the idea was to motivate our engineers to experiment with new technology, new way of doing things, right? So the thing is, we had a vision, not an architecture, because following the philosophy of the department, we don't impose things. We expect our engineers to come up with solutions. We show them that we have our need, which kind of features, needs the company, and the vision that the company has. And the department come up with solutions, and together with our director and our senior developers and tech leads, we decide how we should do it. So the main mission of this project was to create an event source-based design to allow us to connect our front-end applications with our services with our service that were implementing our many domains. And to do that, we create a virtual team composed of many different team members from different teams. So in order to actually, at the end of the project, they would come back to their team and spread the knowledge that we generated during this project. So the team was composed of a few backenders, few frontenders, QA engineer, product manager, and agile coach to help us still experiment, but still keep doing things in an agile way, right? So the main focus of the team was we had to invert the flow of how we actually were developing things. So before, the backend engineers were creating APIs, taking a lot of decisions that at the end, our front-end team will actually have to struggle and figure out how to use the APIs and implement what they need to implement. So in this project, we tried something new where the front-end, back-end, product manager, they were all working together to decide on how the data structure, how the data should look like using GraphQL schema. And then the front-end applications and the back-end applications should comply with those decisions that we took during the schema mob meeting, right? Talking about schema mob, so one of the main responsibilities of our product manager was to actually try to figure out how new ways of reducing the friction between the business and the engineering team. So basically bringing, trying to create the awareness that the engineering team has to use our ubiquitous language, which means that we should use the right term that the company is actually using in the many different departments that we have in the company inside our implementation. So instead of using rides, using bookings, using services, different aspects, using guests instead of the customer users. And this were all brought by, all of this we took in consideration during the schema mobbing, which were the meetings that we had where we were deciding how the data should look like inside our GraphQL. So our vision was basically our system has to continue to be fast and even faster, and has to continue to be reliable and even more reliable than it is right now. Our system is basically used around the globe, so it has to be available, no downtime, as much as possible. Everything has to be event source. The whole architecture has to use event sourcing, but we should keep in mind, we had to keep in mind that this architecture had to comply with GDPR, which means that our events, all the events had to be anonymized. So, which means that any developer catching an event should not be able to identify any user, should not be able to see any personal information. And of course, all of this has to be scalable, and we were trying to reduce as much code in terms of infrastructure as possible, which means no Ansible, reducing the cloud formation, delegating everything as much as possible to services like AWS, right? And trying not to re-implement things like authentication. So we had a similar, let's say, drawing. This is like a more generic than we had originally. We did some modifications to actually share with you, but basically this is the whole idea. So we had the idea was to have two different GraphQL, one that was a customer-facing GraphQL interface, and the other one was for the service suppliers. So basically everything has to go through the GraphQL, every single domain were being aggregated in the GraphQL, and all our different customer applications and service provider application were actually fetching data from this GraphQL. And we even had some extra API, RESTful APIs to easily help us integrate with external services. So, and now Jose will guide us through our code so we can see how we actually use Go.
Hi. So, okay, let's talk a little bit about why we use Go, or why do we choose it. One of the main things that we wanted to test out was building these small domain services that were mainly focused on being aggregated through a GraphQL layer. All of these services will communicate between each of them using event sourcing and CQRS concepts, in the sense that they will react against events and they will send commands to other services to do other things. In the company list during the last years, there was a high level of Ruby development. So MVC and Rails was a set thing in the company. We kind of move away from that. And we move away into this testing about really distributed systems and distributed services. So we wanted to see how small could we go in each one of those services, and how unitary can they be. From testing side, we managed to see that we were able to find a structure on our Go code that allows us to write good unit tests, but at the same time, it would allow us to put it inside a Docker environment and test our connection to the database and the way that we did queries and scans there. This is really important because when we started developing with Serveless, Serveless Offline, which is the tool that you will use to run the environment locally, it's not available for Go. So how do we manage to work around this was built by building the infrastructure inside of the Docker environment. This is mainly the architecture that we had. So there's a few apps built on React that authenticated via Cognito. And once they authenticated, they will hit our GraphQL layer with the credentials that they got there. And the API gateway, so the API gateway is the one that aggregates all of the different Lambdas and gives it like a API form. So the API gateway actually authenticated the request before it actually got to the Lambda. So that means that when we started coding these small Go Lambdas, we didn't have to worry about authentication. If you can see here, there's consumers that are not on Lambda. That was because we decided that consumers had to be running all the time. So we built instances. We used for this normal EC2 instances, but you can actually build it in Kubernetes or whatever you want. And the last piece of that is a Redis engine that we were using for PubSub. So any subscription from the GraphQL layer was running against that Redis engine. So the important thing here is that GraphQL is going to aggregate all of the different endpoints, all of the different services. And the API gateway is aggregating all of the different Lambdas. This is the structure that we decided for our projects. So we have command users. They will hold the actual files that will become binaries. And then on the internal folder, we have all of the different business logic packages that we built, that we created, calculators, commands, database. But I want to pay special attention to the handlers, because the handlers were these classes that we built that will go into the Lambdas. And check this serverless YML file, which is the file that has all of the configuration of how our API gateway and Lambdas are going to be linked, and the different CloudFormation resources that we use. So for example, the configuration or the structure of the DynamoDB table or document, it's actually inside of this file. On the make file, you can see here that for each and every one of those CMD users show, CMD users sign up, all of these different classes, we map them into binaries. And on the serverless YML file, we define all of the different endpoints that we will have, and we map them to those handlers. You can see here that the handler is mapped to the bin, to the binary, and then we have the path and the get. And you can see that in the path, we can use path parameters. On the right side, you can see a normal one of these CMD files. And in here, we're just using dependency injection to build up the connection to the database, and the adapter class, which is a class that we created to fetch the information and to write information into the repository. So we use dependency injection to inject it into a new handler. This is important because in tests, we're going to use that dependency injection to mock that database. In the handler, this is how we create one. So you can see that we receive the adapter, and then we create a function to respond it. This actual function that runs is on your left side right now. So it's quite a bit of code, but it's really simple. If you see, it receives a request object, and then it receives the adapter, and it uses the request object to fetch the path parameters, then the query stream parameters. Now we use the adapter to fetch the information from the database. We marshal that information into a JSON, and then we build up the response. Pretty simple. And on the test side, we just build a test table with different parameters that we're going to send and the responses that we want to get back. We build the request object. And then in here, this was not the final solution, but we wanted to show this. Our first iteration to building tests was by using Dynamock. Dynamock is a library to mock DynamoDB. It's really helpful to get a quick working test. The problem that we ran with Dynamock was that the responses that we got were static, so we couldn't actually test how the scans or the queries behave depending on the parameters that we sent, especially the scans. So we managed to get another solution for that, which was building the Docker environment. I'll talk about that a little bit later. But you can see that we're just building a new adapter over that mock DynamoDB, then creating the handler, and then running the test against that. So what solution that we came up to be able to actually run our code and know that we could actually test it against something that will be close to production. Maybe not production, but something that is close, at least engine of a database that actually behaves in some way like a database and not responds static responses. So we use Docker for that. We downloaded a DynamoDB image that will be used by Serveless to create it, to create the document. And then instead of using Dynamock, we would just connect to that instance inside the Docker environment. This gave us the upside of being able to test the scans, with the downside that tests will only run inside of the Docker environment. but that was okay for us. You can see here that we're initializing on serverless DynamoDB start. So I'm going to show it a little bit on the next slide, but DynamoDB will be just a keyword inside of the configuration file of serverless. And in that configuration file, you will define the host, the port, if it's in memory, and a seed file if you wanted to. And then you can put that seed file inside of the repository. And once that you do SLS DynamoDB start, it will generate all of the documents, the structured documents that you need, and then it will seed them. And I'll give the presentation back to Giuliano to go over the final learnings. That was about it with the code.
So with this project, we managed to learn a few things, really important ones. So basically, we were able to break the ice between our engineers and Go. So we showed that we can actually build something really complex with not a lot of effort. And we even had some examples that some senior software developers in our team, they never had any contact with Go, and in 1 month they were able to do things like you saw, so, and understand everything. So basically, it's the learning curve is really not that difficult, let's say. So the project demonstrated that we can build composable APIs using many different Lambda functions, and without actually care about a lot in terms of authentication. Of course, we still have the authorization, but if set of Lambda function were responsible to handle the authorization logic by itself, but we wrote libraries to do this. And so no big deal. The deployment was insanely fast, to be honest, because our current process takes more than 5 minutes for sure. And every time we needed to run the test and deploy, it was taking less than 5 minutes. So really way faster than the current scenario that we have here. So one thing that we have to say is Go is not like a silver bullet. So basically we could not implement everything. We decided not to implement everything in Go. GraphQL, for example, we use something called Apollo, which is a Node.js with TypeScript. So it's not like we would not advocate to use Go everywhere, but it's, for example, right now we are doing other projects where people are seeing that, okay, it was easier to do this whole thing in Go. So we are trying Node.js here and there, and yes, so it's easier for sure, right? So Go is right for the environment to build small Lambda functions. So that's what we have to say. And yeah, we are really happy that we had this proof of concept, this prototyping, and now we are applying all the knowledge that we acquired during this project in many different teams, including myself in my own team. So now we open for questions. And we go back to our host.
Question? All right, first one is here.
Yeah, I have one question. So how you are handling the code sharing part amongst the different services on the Lambda level?
So we didn't have many problems in terms of code start, but you saw that we were using some instances instead of Lambda in some places to avoid this kind of problem, right? But we didn't have the problem, but we were aware that it would slow us down, and we have many different options. In production, we can do many different things to actually keep the Lambda running. For example, you can provision a little bit of time, right?
Okay, makes sense. Thank you.
Good. Any other questions?
See somebody raise their hand.
Can you hear me?
Yes, we can.
Cool. So you showed the main .go file, or probably where the main function was, and there was a connection to a database without any parameters, without anything. If it was production code, how this library knows where to connect and so on. And how do you know which parameters and how to provide? Probably it reads some parameters from the environment, but how the developer can understand what should he or she provide to this database connection?
Okay. Yes, that's definitely. I actually have the code in my drive in the screen right now, so you can actually take a look. One of the things is that since the Lambdas are running inside of the AWS environment, and the same happens with the DynamoDB tables, so the connection between them, it's way easier when you're running inside of a Lambda. You can see here that if you go to Serveless, we define the resources. So let's, first off, let me see if I'm going too fast. But maybe this will give us a clear picture. So this is the serverless YML file. In here, we define not only the structure of that DynamoDB table, but we give access to our Lambda to access that table, to access that resource. So if you can see here, we're giving an allow to list the table, to describe the table, to everything, to the user's table ARN. And that's how we did it on production. So on production, we just access the resource.
So am I right that, let's say, the database library encapsulates the connection to exact AWS environment, let's say exact names of variables, and you know how to reproduce them in your local environment in Compose, I think, and it's enough.
Yes. Okay. So so to get the database connection, you can see that for local we do something different that we do in production. So for local, we actually are accessing a local resource. So we have an URL and everything, but with the production environment, we access a session, a chair session config state. And then we use that to access the DynamoDB table. Okay,
so if I want to run, let's say, this stuff on my local, so I need to change new database new or DB new to DB new local.
Yes. So in order for this to work locally, that's what we did. So we first created DynamoDB instance inside of Docker environment. And then for the test, let's see if I can actually get a test in here. For the test, create an adapter. It's searching. Okay. So when we do a create adapter, we do a database, new local, and then we specify where the resource is.
Oh, now I see.
Which is kind of different if we were like doing it in production, because in production we wouldn't actually define where the resource is. We just define the name of the resource.
Okay. So when you run it in your Compose, it will connect to actually local or via proxy to AWS.
No. It runs locally. So when I run it inside my Docker Compose, I run a DynamoDB instance, and then I can actually perform queries and scans against it, and I can create collections and do whatever I want.
Okay.
So that's how we managed to test our code. So when we run the test on that Docker environment, we run it against this Docker instance. And then outside of it, when we deploy it, we actually use the AWS one.
Okay, thank you. Another short question. I see you're using GraphQL a lot. Do you have any problems with caching stuff?
Maybe not problems, but we definitely did had a learning curve in there, because sometimes the resources will get cached and we wouldn't see the changes that were happening. So what we did, it's beyond the scope of this talk, but we had to work around the components that do the caching layer on Apollo, and kind of figure out what to cache and when to cache it.
Okay, thank you.
But it's like a double-edged sword, because sometimes it works great, the cache layer, and sometimes it kind of hurts it.
Yeah.
Okay.
Like anything else. Thank you so much.
Yeah.
You
Yeah, I have one more question. It's a very short one. So basically, like how you are handling the database connections for each request. So what I understood, like since it's Lambda function, so for each request, it would become for few it would execute, and then that specific Lambda function will like after completing the execution, it will close, right? So for each connections, how you're handling the database?
No. So, okay, what happens with Lambdas is that they're actually so the cold start, what it does, it creates a process. And then the process starts to listen to a port. So it starts to listen to like a socket. And then every time that you need to execute the Lambda, then you place information inside of that socket. So it's important that, let's see something right here. Users main go. So one of the things that are really important is that's why we use dependency injection. That's why it looks like this. So we initiate the database connection outside before the Lambda starts. So we initiate the database connection, and we initiate all of the dependencies that we need to inject. And then we start the Lambda and inject those dependencies. So as long as the process, in this case, the Lambda is up, meaning that it won't do a cold start, then it doesn't have to instantiate any database connection, or the database connection won't die.
Okay. So let's say if you have like 1,000 parallel requests, so in that case, the open connection would be reused, right?
Yeah, exactly.
Okay, makes sense. Yeah.
Thank you. Yeah, cool. Any other questions?
Yeah, I have a quick question. Can you hear me?
Yeah.
How was your AWS billing affected by using Lambda functions?
Oof, it was actually a surprise. It was really cheap. I think I'm not sure how to test it, to explain it. Maybe you can.
Now, we were surprised because we had other services like our Kafka cluster and our other instances. And the thing is, the Lambda function, we really need to use it because it was really cheap. You know, the only thing that we were impacting us were our own Kafka cluster, all the other clusters that we were using, but the Lambda part was insanely good in terms of cost.
Okay, thank you.
Welcome.
So Omar raised the hand, and now Julian raised the hand. Omar, did you ask your question?
Yeah, so I have a
No,
question.
not yet. Actually, maybe I can go.
Yeah.
Sorry.
I was wondering if you had like any problem with the ecosystem regarding writing lambdas in Go. I remember like last time when I looked into something like local stack, which is like a mock of AWS, they had only support for JavaScript, Python. How did you do for your like integration test and end-to-end test?
Okay, the thing is, everything that we did, we were trying to actually not have the problem that you said, because since the beginning we noticed that, okay, we are not going to be able to use such thing like you said, the things that you said, because we need to have full control and understand everything that we were doing. So basically we create the whole environment using Docker Compose, and DynamoDB, local DynamoDB, all those things. All the rest, it's basically, we have individual tests, but we would never try to rely on testing the whole flow all together in one single place. Of course, we had some tests that were actually like integration tests, hitting like a sandbox environment. So that were from time to time, every time we deploy something, it was running. But locally, we would not try to reproduce the whole infrastructure. We didn't see the value of doing this, to be honest.
Yeah, I think mainly the main the main workaround that we did was we really relied on testing, and unit test and writing integration go test because we couldn't run the environment locally.
Would you say that was a lot of work, like in comparison if you used like Node.js or Python?
Now, what we said, it's actually we feel more comfortable using Go than Node.js because we think it's way less complicated when the complexity of the code is way, let's say, slower than using Node.js. But of course, in some teams, we have to use it because we have to get a consensus in terms of technology. So, but in my case, for example, personally, I think it's way easier to use Go to do such thing like this.
Thanks.
Julian?
Yeah, my question is about this case that is shown in the screen currently in the warm versus cold start in Lambda. I believe that Amazon has a way to, because it currently has how this is set up, every time that Lambda is executed, it's gonna instantiate the database. And it's gonna pull the data from the environment variables. So if you really want to...
It only does that when it goes from a cold start. Once the cold start has passed, it never that code has already run.
Take a look at the way Amazon has documented this in the chat. So I ran into the same similar problem, and the solution was to actually use an init function where only when it's instantiated the class or the package, it's gonna call that data, it's gonna create that database object only during cold start, but during warm start, that's never called again.
Okay, so one thing is the database, we didn't have any kind of problem like this, to be honest. So maybe, I don't know, we kind of don't understand what you said, to be honest.
I mean, it's not a problem itself. The only thing is that you're gonna do more requests than needed. That's the only, you're gonna, at the end of the day, you're gonna pay a higher bill to Amazon because every time the function is called, you will hit the database probably.
Not in our case, to be honest. So we didn't have this problem, to be honest. So basically, we didn't have this whole thing loading database, as you said. So I don't know, maybe we don't have the same scenario.
Well, okay. So I guess the only way to test this in your case is to add a log in there to see if every time you call that function, that log is printed.
Yeah, definitely. I think it's really interesting what you brought up. We'll definitely check it out and see if we can improve our code.
Yeah, that's not, I mean, it's not a problem in performance or anything like that. It's just a problem that maybe if the case that you're calling that several times when your function is triggered, then you will pay more money to Amazon. That's the only issue that may happen.
Okay.
Any more questions? All right, then I guess raffle now. Anderson, do you want to do this now and announce it, or do you want to do this now and announce in the Slack channel?
Can you hear me?
Yeah.
Yeah, I think we can do now. So does anyone else still want to join the raffle?
Maybe you can say again quickly what you're raffling and how to join.
So yeah, we are raffling 80 euros Blacklane ride that you can use wherever you want. So yeah, so you're gonna receive an email with the coupon code that you can add when you are in the ride checkout.
And to enter the raffle, you have to click the link that Anderson published in the chat.
We only needed name and email. And of course, we're going to use only for the raffle, the name and the email. So far we have 16 people. Anyone else wants to do it? 10 seconds. And then, so to raffle the thing, what we're going to do, I'm going to run, of course, a Go program to draw a number. Aha. And then we're going to look who got it. Can I share my screen?
Go ahead.
So can you see?
Yeah.
Okay, so I'm going to stop now accepting responses, right? So these are our people. And then we have 22. That's 20 people. I mean, from 0 to 20. And then, of course, is a proper draw. Number 16. That is Puvilas. You won the ride. So
congratulations.
Yeah, in a few minutes you're gonna receive an email.
Nice.
With the coupon code, and then you can download the app and enjoy what's probably gonna be one of the best rides that you had. A tip from Pro, well, in times of coronavirus, is not exactly the best, but iPod pickups is the best thing to do with Blacklane. But just be careful with the location that you're going to. Okay.
Oh, all right, so now to the fun part of the 20 seconds HR open mic, where you can tell us you're hiring or looking for a job or looking for a contribution to your open source project or an open source project to contribute to or help with a meetup and so on. And 2 raised hands, cool. I didn't catch the names, but let's try to do this in a second. Okay. And after that, some quick announcements from the meetup, and then we will continue to the Slack group, to the Berlin channel, to socialize. So I am setting my 20 seconds timer, and I guess, Blacklane, are you hiring?
Yes. Right. Yeah. Okay. So
timer starts. Go ahead.
We're always looking for great programmers, especially Go programmers. Yeah.
Spot on. Okay. Anybody else? Alexander, go ahead. 20 seconds.
Hi, can you hear me?
Yeah.
Hi, this is Alex Panasek. I'm the CTO of Spot9. We're basically Germany's next digital bank that we're building to provide retail banking, traditional products, as well as cryptocurrencies or digital tokenized products. Like N26, we're hiring all kinds of Go developers. It's in our tech stack, and we're building our mobile banking app at the moment. And we're about to launch crypto ATMs throughout Germany, the first regulated solution. So come join us. Check out spot9.com.
30 seconds is out. You can cheat. Thank you.
No worries.
Anybody? Who's next? Raise your hand. Elias, 20 seconds. Go ahead.
Hi everyone. Actually, it's the first day joining this meetup, and I recently joined Ecosia as engineering manager.
10 seconds.
And we are hiring Go, Python, and JavaScript programmers. And join us if you want to have a job with a purpose and planting tree and saving the climate.
Perfect. Who's next? I could share my screen, but I'm doing this from the phone because I'm not sure the Zoom will be recording that. But thanks for the suggestion. Anybody else hiring or want to speak? Raise your hand. If you're not sure how to raise your hand, you can start speaking. I'll start the timer.
Okay, I also can a bit promote in 26, another digital bank. And we're looking for site reliability engineers or system engineers with the good Golang skills.
10 seconds or you're done. Okay, perfect.
Yeah, I'm quick.
Thank you, great. Who's next? Going once. Going twice. If you're not sure how to raise your hand, you can start speaking. The chat doesn't count, I'm not looking there. All right, then I guess we're done with this part. Then some announcements from the meetup part. So the next meetup will also be remote, will be in a similar format, and will also be recorded. And hopefully in May, we can start having the meetups in person again. We appreciate people who raise their hands now. You can talk later, not for the HR session though, I guess. So May meetup hopefully will be in person again. Blacklane, thank you for volunteering to host us here in March, and we will meet in your office hopefully in our next available slot, which is probably September, potentially October. Some conference updates. As you saw, .go was unfortunately cancelled. GopherCon moved to July, and GopherCon US is taking place as planned in June, and GopherCon UK is taking place as planned in August. If any of you want to submit a talk to any of the open events, please write me on Slack. Happy to help you write your call for paper and work on your talk. So there were more chats and more raised hands. Go ahead. Alexander, you seem to be raising your hand now. Do you want to speak?
No, I just got my question answered in the chat. It was about how we can participate and present on our different projects. So I guess we will apply through the meetup. Somebody posted there's a link there.
Yep, perfect.
Great.
All right, then thank you all for being part of this cool adventure. And the talk will be online soon, as please continue to the Slack group and let's keep chatting there. And have the rest of your evening. Enjoy it. Bye-bye.